Okay, good morning. Am I audible?
Good morning. Yes, sir. Good morning, sir.
Morning. Okay, okay. These are kind of like you try the exercises of extended dimensions for the signal case. Like, what would be the you have to know what would be the signal of this one in 2D. This is actually is in 1D. What we see this signal function, and then what would be the corresponding 2D analog. Once you know the 2D one, then you can able to construct this a single cuboid. From that you can able to make the approximation uh, with the cuboids. Okay, these are all like okay various couple of exercises. You try them. Now today we will move on to next versions. Okay, so you may have already seen kind of tools in the market or in the internet. um, suppose suppose you find some distorted information. It is not original. Maybe it's a kind of like damaged pieces. Within this there are a couple of pieces are damaged, or you can say like a picture or something, a voice or anything, any data entity which is which is partially damaged. It's not completely damaged. Completely damaged, we don't say it as it is same thing as original, or there is no information about the actual one. Suppose there is an data which is partially damaged, and we can see some kind of systems, network systems or intelligent systems. When we pass this partially damaged ones to this uh, system, we can expect a perfect picture without the correcting damages. There is no damage at all. It will produce an image or any piece of information which which is corrected by itself. So do you have any such tools or examples? You know them? Because I'm not much aware of them. I use it, but I know that they exist with particular websites or apps. They do this. Do you know any? But not just for the photo or anything. Anything, a sound or a text, or if you supply some partial information to it, and it will fills the gaps which is destroyed or intentionally unfilled gaps. It will bring back those information by filling them, or trying to bring it original form of it. Is there any such tool? Have you tried using it? Even in the text, like text is something different, I could say. That is completely not, you can suppose if you supply some statement which is incorrect spellings or configuring the grammar things, then you would expect a kind of like corrected sentence. Usually you find them in the chatbots or the language tools. That is also similar properties they use it, but more general in any form of data which is destroyed, and then we are trying to expect some kind of a repaired or perfect one. So so far what we have seen, that is this is a f of x belongs to neural network, that we generally bring them as a sigma n. I don't remember exactly what is the notation. uh, Sigma g of x or c is sigma g. What was the notation? I need to go back then. What is our sigma net notation? Yeah, sigma n of g. All right. Okay. This is sigma n of g. G is the activation function. Based on that, we get this sigma n g. Okay. If we know this one f of x, and does this the sigma net does the job of what I prescribed here? Anyone can guess it? Does sigma net does the job of correcting? It's just not predicting of what we are, yeah, supplying a new feature and getting a new feature, and looking for kind of like partially supplying information and getting the original feature, original information. Hello, am I audible first? I don't see any responses from you. Yeah, good. You are getting the difference, right? What we discussed so far, the neural networks are function approximators, supplying generalizing the any data, looking for any unseen data to build the answers. But now the answers are, we are not interested in the new answers, but the original answers. What we have developed that f of x with the data, or which now if we supply some partial data, and can we reconstruct them? Give a think for a couple of minutes, so it will set you a kind of a plateau to proceed further. So okay, can you uh, describe the mathematics to express uh, something. If we give something new information in from the sigma net, like if you supply x to a neural system, whatever system what we built, and we are looking for f of x. Okay. Now, if you change x, x may be anything, data, or it need not be just rn rm. It can be any data. It can be kind of like picture, or it can be music. It can be anything. And now, if you change a little to the original information, and now, uh, what does the sigma net do? So, do we get? We are trying to get f of x plus delta x. That means, do we get this one? Do you think the neural networks has this one only, or something else? You understand well, right? The neural networks, the sigma nets.
Yes, sir.
Yeah. And so, what do you say? Like, this one is okay. You know this one. That is what we have many times we discussed. Now, if I change my original information to something else, that is delta x, do we see f of x plus delta x, or still f of x, or still f of x?
Sir, f of x plus delta x, sir.
Yeah, that's what the because of the nature of the f of x is continuity, right?
Yes,
The
yes, sir. That's right. Yes, sir.
the f of x is the continuity. What continuity definition is says about? Continuity definition says, like, if you have a ball around x, like, okay, instead of mentioning the ball and all, like, I can say in general, if you have f is a function from rn to rm, and for any x, belongs to rn, um, if norm around x is less than delta, I can say, which is implies norm of f of x dash minus f of x norm less than epsilon. You can say this one. That means a given epsilon greater than 0, you can write up, I'm not writing all, there exists delta greater than 0, such that all these things happens. So that means, like, continuity is a kind of like, if you have um, an x, and if you have f of x in our codomain, the ball around x is delta neighborhood, f of x, and this one is epsilon neighborhood. No matter if you move this within this some delta x place, any small distance, if you get something like x plus delta x, I can say, if you are in this, definitely you will get somewhere within this, like f of x plus delta x. So it stays inside within the epsilon neighborhood. That is what continuity definition says. So you get a x, you have a f of x. If you move little bit away from the x, and similarly it will go away from the x plus delta x within this epsilon. It is, do not go outside of this one. For every whatever choice you choose, epsilon here, and always we can find a neighborhood around x, such that these are all fall inside within this epsilon neighborhood. So you do not go, you do not escape from that, so that you can decide what approximation you would like to be. So epsilon is a deciding thing, how much close you wanted your ball to be around it, around the answer. So you don't expect something like very odd, take something very large epsilon and looking for a large here. So this is the approximator epsilon, so that you don't get very completely different information what you pass it for. We look for similar information, that is we are expecting something like there should be at least. But now I don't want that. Now my x is original and my x plus delta x is something distorted. Something distorted means that there is information is left off, but I want still f of x because that is my original one. But delta x is causing damage, some damage due to on the data. This data, if I supply this damaged version, and you will get a damaged result as well, the corresponding one. That is what the continuity does the job. If you supply x plus delta x, you get a f of x plus delta x rather than f of x. So there is a slight disturbance in the input output as well. But now I don't want that. We are looking for a very interesting feature, correcting the anomalies, correcting the errors in the data. So now I am expecting rather f of x plus delta x, I'm expecting this one, this f of x. Okay. So now how do we achieve this? Anything of it? You understand what I'm talking? This is not just mathematics. I'm reading all the mathematics, but it is a core building block in the technologies. What you see in the market or in the real world.
Yes, sir.
Yeah. So now, how can we achieve that? Repairing or predicting the original one. So what could be the system we should develop here to achieve that? So clearly, our sigma net doesn't do the job unless we modify or unless we do something within that. These are all concepts or applications on the top of neural networks. So every new idea comes to the play, and accordingly we need to adapt and change the systems or uh, identify the modifiable pieces so that we can achieve what we want it. And these are all kind of like concepts we can discuss, but in real life when you go for work on models, or if you are developing really a new system or new construct a new building block for a solution, you should really have to think on these things. What you are facing right now, the question mark here, uh, this is the just a simplest one, or maybe a simplest idea. But in the if you are sitting in the position of really building a new construct, a new idea to do that, so you stop at this point and you have to really think on that logics. So that logics may not exist in the world. So for that you need to build a core concrete mathematics to bring that ideas uh, uh, into developing a kind of mechanism. So that is the one where you separates it out of the out of everyone who is in their field or career. So now how do you think on this? How do you apply your logic or reasoning uh, to achieve to achieve the f of x. Give just you think on them. What so it is not a completely different what we are discussing. It's we are on the track of doing the same thing, but a slight modifying. Anyone, please? I see many of you today. I'll pick someone. Sonam Kumari. Sonam, are you there? Okay, she is not there. Ganapati. Hello, are you there?
Sir,
Yeah.
in my opinion, sir, here activation function is the main role, sir. Like
Hmm.
activation function does the that things key it converts that value into our previous value. I am confusing between, so like if we take x plus delta x, then we multiply with our in hidden weights, then apply
Hmm.
activation function, then multiply with our output weights
Hmm.
summation, then how this value again becomes same. Then I am thinking that there is activation function that will do.
Hmm. Yeah, and like yeah, how can that could happen? Like activation function maintains the same f of x. Like even how long I should maintain, that is also thing. The thresholds. This f of x plus delta x. Suppose if you pass this x here in the delta region, in the epsilon region, it should give the same f of x everywhere in this whatever you pass on this delta. Oops, sorry. Wait a minute, it is stopped. Yeah, whatever you passed on this delta and everywhere it should show f. So what is the mathematical construct before touching that activation function? I'm talking about not the neural network design, how the activation function or something else. We'll see that later. Like in the fundamental core piece, this one we targeting everything, entire ball to the center, right? So that distort this we anything comes from this delta region, it should represent the same f of x. That means it identifies x as this identifies x as it is something as damaged, and there are damaged versions of x are sitting here. All these are damaged versions. Whatever damaged versions you give, and it will give the f of x.
So then one thing is there, so like we can add some condition like x plus delta x if great less than this bias. Here bias our play at a epsilon. Yeah, delta, either then our value will come fx.
Hmm.
This kind of condition, sir.
Okay. So the conditions you are taking in the language of putting in the program, but I'm not thinking on the side of the data, because these conditions we don't keep it. These conditions or whatever, it should be done by on its own, because we don't know the conditions for the data. We don't know the what should be the limit of that one. We don't know what kind of data you use it. So we need to build some kind of learning system that learns automatically. That is what neural networks does the things. So we should not put the conditions on that data, because that the we should develop a system that takes care of all those conditions. We never did any kind of conditions on the W's. Like, we know the answers of many things, like this one and this one, all these things. We don't give any conditions. There is a line, there is a separation. It learns on its own from the data. We can't condition them. And even we are not having enough information about what, how do you define X is partially destroyed. What does it mean actually? So now in the theoretical sense, if we talk all these things, like if that is a concept, uh, maybe.
So,
Yes, yes,
so
please
one
go.
thing more we can do, sir,
Yeah.
starting from the input, sir, we go till the desired outputs we have. Then, sir, we
Mm.
calculate the error. The one with the minimum error, it will go to that image, sir.
Okay. One with the minimum error. Um, so like so you are supplying a picture, and you are looking for this one, and but you don't know this one, right, to get the minimum. The question is about the, as you are said, like, okay, that's we can consider it as a nice idea to think of it, but the question of availability of this originality, this we don't have. So we don't have. The neural network is a kind of like, it is remembered some patterns out of training, and we gave something this one, and maybe this is this is a particular pattern but destroyed, but it is not trained within this network, and but we are supplying this one, and there is no equivalent version is sitting there. Then we cannot achieve the what could be the nearest, or what could be the closest distance from this one. We are not having that. And yeah, even um, these networks, whatever I am saying, these may not be the procedures, these may not be the procedures of training of the same way what we have seen, like the backward process, the error, all those things, because this kind of we are not looking intentionally here supervised learning. It is a kind of like unsupervised. We don't know, or even supervised also we can use it, but most of the time the neural networks are pattern remembers. Like, okay, let me go ahead and touch the point. So, um, so like,
Excuse me, sir.
yeah.
Sir, your screen is not visible, sir.
Okay, sorry.
Oh,
Something has happened. Okay, now is it visible? Uh,
Yes, sir.
yeah,
Yes, sir.
okay, fine. Uh, okay, I will start up with a few new terminologies or new conceptual developments which were mathematically so strong. uh, I don't know in the technical world what these names are called. Different resources or different places, different authors are write in different ways, but I will write them what maybe the these are called. These are all not no more artificial neural networks. These are all like associative networks. Associative networks, maybe other names kind of like associative memory, or maybe associative learning. These are all like, the similar for me. The core ideas are same. They are slightly differ in the namings, but let's talk on the concept, what they deal about it actually. Okay. This is what the brief intro where we connection between where we started with the sigma nets and the artificial neural networks, and how the associative networks differ in terms of artificial neural networks. This is simply this is ANN. This is what we discussed this one, ANNs. So now something called associative networks, not artificial neural networks. These are all kind of like associative memory. Um, Usually it is named as associative memories. Now, um, let me extend the discussion, the earlier one. Suppose if you have a network, I'm not talking about whether what network it is, some system which is mapping the vectors, or mapping the vectors, input vectors. Let's say a vector x bar, I could say x bar, to uh, to y bar. So x bar's answer is y bar usually. So if you have uh, such vectors x, let's say x1, x2, and so on xm, uh, this one, how do I call them? Okay, this one, give me a minute, like I don't want to pick some kind of notations. um, so if I have xi, I can take it as a yi, and if I have the dimension of each vector is n, and if I have i's from 1 to m, there are m such vectors. We are trying to find out association. That means like we can say that mapping. Then what we write up something called, if I have m such vectors, m output vectors y1, y2, so let's say uh, x1, x2, x3, and so on. Let's say xm. These are all not the just numbers. These are the m input vectors. Each one belongs to Rn, n-dimensional space. And now we have y1, y2, y3 and so on. Ym belongs to, this is also from, I don't think of, I will take from the n dimensional, I will take from uh, something m, we have already used it, so I will use something called here k. Otherwise n and m we familiar with it, so I will keep k. So I have n dimensional and m dimensional output uh, for everything. Now this is a kind of like association. So x1 is associated with y1, y2 is associated with, x2 is associated with y3. So this association is the kind of like, the mapping. The m vectors in the input space is mapped to m vectors in the output space. So this is xi is mapped to yi, if we write up this one, each from the different domain space. Now what do you say? uh, the learning algorithm, the system, what is sitting between this one, uh, if the norm xi minus the norm xi minus okay, no, I don't call it as a xi. There is, if you take some x tilde, I could say x tilde, then this is xi bar. That means like, if you choose some x tilde and then there are xi's around, or if this one is the norm of this one is less than epsilon, that means if it is in the epsilon neighborhood, then then x tilde is mapped to, can you guess what could be this, where
Why
it would
tilde,
be?
sir?
No, if it is y tilde, then it is very clearly the ANN, artificial neural network. We are not looking for the anymore. We are looking for the closest x tilde one. This is the, you can think of this one as the destroyed one, which is original one, which is the approximated within the distance epsilon, right?
Why I bar, sir?
Yeah, yi bar. We look for yi bar. So now then x tilde is mapped to yi bar. This is completely different from continuity. Don't think of this as a continuity. This is a completely different from continuity. That means like we are kind of making something away from the continuity principle. Okay, it's a kind of, you can think of that discontinuity. We are making some kind of surface flat there. We don't allow the surface to be bent. If it is bent, then we will get the different answers. If it is a flat and the codomain, that means in the solution space, the answer space, then uh, then what you will get it, like if you supply the anything between around x tilde, you will get the same answer sitting on this one, like constant piece. So so if this ball is associated to this one, this piece, this single piece, the solution yi bar, then no matter whatever you give it within this region, you will get the same yi answer, because that is a same solution it is representing. So we are not allowing the continuity there intentionally. That is violating the continuity principle. The violation of continuity principle definitely brings a kind of step format, so that there is a step there. That step is holding the information around xi as the same. So the next step, if you take a next ball, something like this one, it may have some step function. The steps comes there. So it may be holding some other association. So it is by intention, if we avoid this one, the if you violate this one, definitely it violates the continuity. So that is, the continuity definition doesn't have any kind of a role here now. But now we are making something discontinuous form of neural network, where we are, that is an advantage, we are seeking it, such that we can repair our inputs mm, with the proper outputs. Okay. In this case, you may get confused, like we started with the same input here, and we are looking for the same answer here. But now I said, like, here it is x, and we are looking for x at the very beginning start, like. But it is x if it is y, and the same y we are expecting, it need not be the same thing. These two versions are there. These two versions have different names. If it is x is passed and we are expecting the same x, that is one system. And if we have x and there is a y is associated, and we are looking for the same association y, and that is different. These two are names as different things. That I will call it as, first one is the association with x is associated to y's, and we are looking for this definition. Let me clear it off so that you can see the condition here. What kind of x tilde is now associated with yi. It's not with xi tilde. It is with yi bar, that is sitting around xi. Hmm? So this one, this is called, uh, the this kind of association, and with this rule, if a learning system or learning algorithm, or whatever you call the neural network or whatever, if any system is doing such a job, those things are called hetero associative networks. This is your concept of next. uh, Hetero, I don't think there is a space. uh, Hetero associative networks. So it is not the neural network, it is not the ANN, it is, there is no continuity principle. And we have violated a major principle. We started with that, the continuity, the activation function, all those things, we started with the continuity. But now there is no more continuity is going there. By condition, by definition, we are violating that. So the association, we are looking, even if there is a disturbance around x, and we are looking for the same y. If that is what the target, if there is, the association should not have any disturbance. Even if you have a disturbance around x, and the association, we look for the same answer. That is hetero association. And what we started with this one, and we're looking, given x and looking for the same x, that is uh, auto association, like auto associative network, you can say that. So next one is auto associative network. So a network which is doing the same job, like if I wanted to write up that auto association, uh, it is a special case of the hetero association, like yeah, auto association, auto associative networks are subclass of hetero association, because it is a kind of same thing, but we are looking for the same features to same feature correcting themselves. These are the heteroassociative networks. So what does it actually mathematically says? Like, hmm, if you have uh, if you have m such vectors earlier, k such vectors, k we written, yeah, k such vectors. If you have k such vectors, then same thing, you replace yi with yi with xi. That means like each xi bar is associated to xi bar, x2 bar is associated to x2 bar, xk bar is associated to xk bar. So then if we are
Sir,
looking for, yeah,
sir, in this case, sir, in each case, sir, like epsilon value may be something changes now in each case, like or x1 is associated with xy1 bar. Then next one is our
yeah, yeah,
maybe.
that the same, yeah, of course. The epsilon is a theoretical thing. The even the epsilon, we have a choice of epsilon greater than zero. For every epsilon greater than zero, we are talking about it. So the choice of epsilon is not fixed. Where no more epsilon is not a fixed thing, but we arbitrarily, the theoretically, even in the continuity also, epsilon we don't maintain the same. Epsilon is a choice by yours. Yeah, yeah.
In this
So
case,
now, yeah,
in this case, our function is sir continuous but not differentiable. We can say like distorted means this one continuous.
no, no, no.
But
We don't. There is no more continuity. Continuity is there
yes,
needed.
sir, as a continuity also is not there because
Yeah,
sudden changes in y value.
yeah,
Yes, sir.
yeah, yeah. You can say it may behaves like a piecewise continuous, or maybe it may not be piecewise if there is no data between them. But theoretically, it is no more continuity. Okay.
Yes, understood, sir. Yes,
Yeah.
sir.
So these are the two associations. Like hetero association is the same thing as I have explained here. This one, if these are all like if your outcomes are mapped to the original x's, x1 bar, x2 bar, x3 bar, instead of something else, and then this association is hetero, and if the outcomes are again the same whatever you supply, then that is auto association. Okay, the same definition is same again. Instead of yi, you will get we are looking for the same picture or same information which we passed for. If we supply some distorted image, x tilde, we are expecting what we are expecting here instead of yi in the auto association. What should be the x tilde should map to in the auto association?
X tilde, sir.
Yeah, this x tilde is mapped to where? No, not x tilde. It should be xi bar, the auto
Yes,
association.
yes, sir. Yes.
Okay.
Yes, sir.
Yeah. So I'm writing this one is hetero association. If it is mapped to xi bar, then it is auto. Okay, don't get confused with both. We are looking for the same xi. If you say even if you xi your x tilde is a distorted version or spoiled version of the data, then we are looking for the original data. That's what we started with. That is auto association. Okay. um, so for auto association, that both the domain and codomain should be same. That is also one thing. It is not just the association. If xk is sitting inside rn, means it should be also in rn. They should not be in the two domains. That is also need to taken care. Okay. With this, now usually Let me draw diagrams of some kind of networks of the networks. Uh, not the not the complete network architecture, but block diagrams, I could say, like hetero associative network is a kind of like suppose okay, this is a kind of, I am talking x1 bar, x2 bar, and there are I could say, no, this is no, this one is um, yeah, okay, one input and one outcome. So if you take n dimensional vector, so that means like if you are supplying some xi bar, that means um, uh, now I have a little problem. I have a little problem with indices. I anticipated, but didn't care much. So, like, if I have xi bar, and within this I have it is belongs to xi bar is belongs to Rn. So I need to mention the coordinates x1, x2, and so on xn. So this notation is a bit confusing. So I just wanted to move everything something different. This is for I will keep in the superscript. That could be better, so that subscripts are indicating for the individual elements, or superscripts for the vector notation. Okay, I'm just changing. If you read later, you should not be confused. Analysis.
Exact word I cannot remember. Dynamical system.
Dynamical systems, that means like you on the fixed point approximation, like if you have a function f of x, f is a function from r to r, and finding it out f of x equal to x. A kind of like if you have this line, and if you repeatedly go with that, and you will get a
Yes, sir, yes,
point.
sir. This,
Yeah,
yes, sir.
the
This
fixed
one, yes, sir.
point,
This
the
one we have.
iteratively function of several times,
Yes, sir, yes,
and
sir.
we are trying to
Yes, sir.
find some that association, that point. So these are all called usually in the dynamical systems, and if the dynamical system has a fixed point, then we can achieve. But if it is not, it's always a kind of like we'll rotate all the time here and there. We never achieve to the point. It falls in 2 cycle, or it falls in 3 cycle, or 4 cycle, or n cycle, finite cycle, or such systems we discuss. But it is actually
Sir,
yeah.
contraction theorem.
Really, how the in the contraction mapping theorem we have something called d of x comma y is less than, or is uh, d of f of x comma f of y, right? And there is a distance if it is changed, if it is after applying the metric of the function, if it is behaving something like smaller distances after applying the function, that means if we say the contraction mapping, or we can say this is simply less than or equal to alpha if there exists alpha such that. Yeah, do you remember this condition? Contraction
Yes,
mapping
sir,
theorem.
yes, sir.
Yeah, some
Yes,
similar
sir.
words. Yeah. So of course the contraction mapping theorem is there, but I don't touch all the things. Otherwise, it is a kind of, we don't go further. So I will bring the matrix theory to make it much simpler language rather than the analytical functional analysis language. So matrix language is much better to explain in a simplest way, and we can construct the programs from the matrix language, so that we will discuss tomorrow. Tomorrow is a 2 hours class, right? Or today?
Tomorrow, sir. Tomorrow. Today we
Tomorrow.
have
Okay.
class at 10 to 12, sir.
Yeah. Sure, sure.
Stochastic
Okay.
calculus.
Yeah. Okay. We will meet tomorrow 2 hours class.
Okay,
Okay.
sir. Thank you,
See you.
sir.
Bye. Bye.